In the previous episode, I bolted this Mercedes OM617 diesel to a Jeep NV3550 by means of the Doomsday diesel adapter, and you might want to check it out if you missed it. First I removed the shift tower and boot, as fitting everything was going to be hard enough as it was. You also notice that various accessories and bits will disappear off the engine during this whole process. At some point I will cover that stuff, but don't worry about it for now. I also bolted an energy suspension TJ polyurethane mount onto the transmission, as I intend to go with polyurethane mounts for increased durability, and the XJ style is way more expensive than the TJ style. With that out of the way, I could actually try for the first test fit. I'll point out that I intend to keep the factory Mercedes oil filter setup, and because of that it should not really be possible to fit the engine as configured. I'd mentioned before that having a tilting spreader bar would be a big help for this, but I definitely was able to make do without one, just with a little wrestling of the engine and transmission. And it was at this point that I realized my spreader bar was hitting the hood, and it would not be possible to continue with the hood in the way. So, out everything came so I could perform yet another awkward hood removal, which I now believe my series is known for. Awkward! Okay, so on to trying this again. And then I hit something that I anticipated, but had not realized would be as bad as it is. Being a front oil sump engine, said sump interfered badly with the steering, to the point that I could not even get the engine into the place that I had wanted it. And the offending steering components were simply disconnected for the time being. Everything here will need to be replaced entirely, likely with fabricated parts, so there's no need to be gentle. Unfortunately, the engine then of course hit the track bar. That should also have been apparent when it would not clear the steering. Anyhow, for the time being, I just removed it. At this point it was very obvious that I was going to need to lift the truck, which was in the plan already, but beyond that I likely would need to modify the oil pan, at least partially in order to produce acceptable steering and track bar geometry. Knowing that I was now close to making this fit, I bolted the factory transmission crossmember onto the TJ mount. Since the mounts are totally different between a TJ and an XJ, this was really only to establish a convenient point of reference. I found that by reversing the crossmember, since they aren't symmetrical in regards to the hole location and the clearance area for the exhaust, and then bolting everything to the forward set of holes in the MJ chassis, I actually could position everything in a remarkably suitable location, with the transmission slightly offset to the passenger side to allow for the transfer case, front driveshaft, and axle clearance. At this point I was able to finally drop the engine to where I felt it actually needed to be as far as height went. Checking clearances, and the passenger side seems reasonable. There's lots of space for the alternator, turbo, and to fit an engine mount in there. For the exhaust, there is space for a 2.5 inch tube to snake its way down near the starter and upper control arm mount. However, part of the floor and the UCA mount will need to go for this to actually work in practice. Along the driver's side everything looks good, given that some things are going to be rearranged. The oil filter housing is a little too close, though there is not quite enough space for a finger all the way around, so the firewall will need a little work. Behind the valve cover it is close to the firewall lip, so some trimming will be prudent here. The height of the hood was simulated with some square tube and careful measuring, and yes, in this position the valve cover will hopefully not hit the hood. The problem with the steering will be more apparent later, but it is a problem. On a straight line from the pitman arm you can't even see the passenger side steering knuckle or arm. The oil pan does, however, have good clearance on the upper control arm mounts and the axle tube, and there is space for a center section of a proper four-wheel drive axle. The transmission is centered to slightly the passenger side, and it is tight to the floor for ground clearance. And lastly, yes, the shifter is positioned where it should be, Not that cutting a hole in the floor would be a big deal by the standards of this project. With the engine back out, I could do an initial removal and cleanup of the firewall lip. I wound up taking some more off later, but I can assure you the engine will be in and out many more times, so there was no need to go full hog on the first round. I also took the opportunity to move the firewall back a bit for oil filter clearance. I know many people will cringe watching this, but the technique does work. The trick is to not hit it hard, and rather just let the metal move as it wants. The hammer has the weight to push it, and the weight is what does the work without creasing the metal. This will need a little more work with an actual body hammer and a dolly to clean it up properly, but at this point it just needed to be in roughly the correct shape. I had a rough idea of what I wanted to do for the engine mounts, and I did a little paint pen artwork to make sure it seemed reasonable. The main idea is to tie in as many mounting points to the uniframe as possible, as it will spread the load and help with the rigidity of other components. What follows is a bunch of simple, low-buck fab. First, my little bandsaw was used to cut out just a few pieces of 3/16 hot-rolled steel flat bar. Then many holes were drilled on the drill press. And very simple bends were put in the pieces using a brass hammer and the vise. A recurring theme while building these was that unfortunately many of the holes had to be slipped a bit. This is because I didn't necessarily lay them out perfectly, plus their actual locations in the uniframe is set with a significant tolerance from the factory. And the odd combination of studs and bolts means things just didn't fit how I'd think. This really is a stack up of tolerances scenario, which is unfortunate, but it will work fine. An assortment of angle and die grinders were used to clean the mill scale off the steel as required. Here's where the first piece will go. The next piece required some more significant shaping, and I generally use an angle grinder for straight cuts like this. With a little practice, you can easily make a nice cut using a thin disc. I could then start tacking pieces together. One thing I found was there was a lot of splatter and some protruding weld around these holes that was left over from factory, and I cleaned it off in order to ensure the bracket would fit snug. This was the same on the other side too. And the next pieces were all made in the exact same fashion. This larger piece is bolted on here, and then this smaller piece will fill the gap. With that done, I could tack the rest of the bracket up, and I added a small piece here as it was a bothersome omission from the start. The bracket for the driver's side engine mount was constructed in basically the exact same process. It just wound up being a bit bigger as it needs to also tie into the track bar mount, which I will point out I don't even know if I will be using given that the track bar does not currently fit at all. When welding all of this up, I tried to jump around and minimize the distortion. I really didn't feel this was my best welding, but I'm confident it won't give me any issues. There was just more grinding and cleanup work than I'd like normally. Because I wasn't super happy with the welds, I did pass over the backside with the TIG. I probably should have just done the whole thing with the TIG, but I'm not as comfortable with it yet. With that done, I could start on the part of the mounts that actually attach to the engine. I used some 1/4" flat bar for this and transferred the holes from the original mounts using a transfer punch and a scribe. And then it was back to the drill press for yet more holes. If you're curious, these mounts do not have the same pattern on each side. It just about got me. Luckily I noticed before making both of them the same. And here's them being fit to the block. For the actual cushioning material on the mounts, I decided to go with Daystar polyurethane bushings, pictured on the left. This is because they're a softer poly than the typical bushing, which is on the right. Hopefully this does not result in too horrible of vibrations. On the chassis side of the mounts, I figured some universal tabs would make for the easiest option. The ones I had lying around had the wrong sized holes though, so I oversized them with the step drill. When using this type of bushing in this application, it's almost impossible to tack weld everything without aluminum weld bushing work aids, as the polyurethane cannot handle even the temperatures that small tack welds will produce. I used some 2" 6061 aluminum bar stock to make these, and they're really something that doesn't need to be perfect. You can also just buy these things already made, but what's the fun in that? These weld bushings are assembled into the bushing housings and tabs as shown, and dimensionally mimic the actual polyurethane bushing. The advantage of these is not only that they can handle higher temperatures for tack welding the pieces, but since they are completely rigid it will align the tabs perfectly. The next step was to ensure that the engine and chassis were actually level to each other, and an appropriate 2-degree transmission down angle was established. There is some assumption when doing this, so I measured from multiple places. From there, the bandsaw was employed to cut down some 2x2x250 HSS, which the end of was then scalloped with the angle grinder to fit the joint body. I used a piece of round stock to simulate this, as it was handy. You could also make the scallop with the tube notcher, or an annular cutter in the mill, but for the setup time required, the grinder is just easier. The tabs also had to be trimmed to fit the chassis brackets. All of this stuff could then be tacked in place, and I'm sure somebody will leave a comment about how I should be wearing a welding jacket to do this. I had enough trouble fitting my arms in there as it was. Seriously, this was awkward. I'll suffer a few burns and a bit of a fake tan for actually being able to get the job done. I then very carefully let the weight off the hoist, as I really wanted to check to make sure I actually had acceptable hood clearance before committing to burning the mounts in. No lewd gesture intended, but there is legitimately 2 fingers of clearance above the valve cover. Then the final welds could be made, and again, I was not so impressed with myself on this. I put some high build primer and black lacquer on these, using the painting technique known as applying it with a fire hose. I find this technique works well for parts that aren't readily visible. Once the paint had a day to cure, I could install the polyurethane bushings. When doing this, it's important to lube them, and I like to use silicone grease. They will go in without any real fight when lubed properly. Then it was just a matter of jamming all these pieces back where they were supposed to go, and tightening down all the bolts. And that said, the hoist could be let off and the engine was finally home. Now mind you, it's going to have to come out and in at least a half dozen more times, so this is only a small battle won in the much larger war. So with the engine in, I think I'll call it quits for this episode. The steering and track bar not working out was something that it didn't really surprise me. I didn't expect any of that to have any hope of working at all. And as it looks like I need probably 4 inches of lift as a minimum to make things work. That's definitely not a surprise. The other option would be some pretty radical oil pan modifications along with a little bit of lift. That's on the table, but I don't necessarily want to go that route. I'd kind of like to get to this to the point that I could just try it and drive it before really ripping into things like that. But we'll see. One way or another, I need a proper front axle for this, the one that I'm actually going to use. I'm not keeping this 2-wheel drive beam axle, and I can't really say the location of anything in regards to steering or suspension without one. And along with the lift parts, you need something to actually be able to set your zero datum and figure out where you're going to be with up and down travel. So that's a bit of a hurdle that I'll have to source some parts for. Anyways, thanks for watching. Hopefully I'll see you on the next episode.